Okay, so today we're going to talk about waves. Today's video is going to be a little different than before. I'm going to be writing in the things that you need to write down on your notes. Okay. Also, let's always remember that this video is just as if I was standing up in front of you. I'm speaking to you about the content. You're learning the content through me speaking. Only this time, instead of the interaction being towards the whole class, it's meant on an individual level. So just want to make sure everybody remembers that as we go throughout and do these videos, because they're actually very useful, and I think they create a better learning environment than me standing in front of the classroom. So with that being said, we're going to go ahead and get started. So we've talked about waves yesterday, and now we're going to talk about not only that we know that there's different types of waves out there, we also know that there's today we're going to talk about, okay, what is a wave made up of? What are the different parts of a wave? And today we're going to focus mostly on transverse waves. We'll mention compressional waves, but today we're going to talk about the parts of transverse waves. Okay, so if we're just looking at this picture, again, this is a transverse wave. The basic outline of this is that there's a top part and a bottom part. Okay, and there's certain vocabularies or certain key terms that we need to know. And I think if I was to ask you, if you saw this out in the ocean, okay, what would I ask you to be? What would you call the top part of a wave? Okay, and the word we're going to use is crest. Okay, and that's the high point in the wave. Okay. However, as you probably could see, that if there's a high point, there's also a low point. Now, this word is not something you normally use, but it's more familiar maybe with if you ever do any kind of farming or if you live on a farm. Pigs that eat food, they eat in a very low position. They call this a trough. So the lowest part of a wave is a trough, and I'll write that down. Okay. Now we're going to move on to the next slide. So the next thing, we are going to mention that compressional waves do have pieces to themselves. And as you can see here, there's two parts to this slinky. There's a very condensed part or a very compressed part, and there's a very open part or not compressed part. So we're going to talk about those two different parts. So the first one we're going to talk about, which is right here, is something called a compression. And I think that makes sense. It's a compressional wave. We're going to say that this is compressed down. So we can say this is a crowded, because it is. There's more spirals there than any other spot, or it's very dense. It's a very dense region. And you need to be filling this in as we go through. Now this part, there's not very many coils here in the same area as this. So if this is the width and we take that same amount, you can see maybe there's only one here, but there's 10 here. Okay, now what I think of is it's rare to find a lot of these coils in the same spot right here. So since it's rare to find that, we call that a rarefaction. Okay, and as you can see, they're very spread apart. They're spread out, and there's less dense regions there. Okay, so rare, not many; compressed, many. Okay, so wavelength. What does it mean to say that if I measure the length of a wave? How do you measure that? What parts of the wave are you going to measure from one end to the other? Well, so from this distance, or from one crest to one crest, that's the length of one wave. So we can say that this is one wavelength. Because as the wave travels, it all looks the same. You're not going to have waves that are going to vary, so you won't see when it's low here and then high up here, low here and then high up here. Those are more complicated waves. The waves we're talking about, they're going to follow the same pattern all the way, so the same height all the way through. So we can say that one wavelength is from the measurement of one crest to another. And we can write that. It's the distance between one point on a wave to the next point. just like it on the wave. Now you could do this with troughs. You could measure the distance between one trough to another, but normally it's the crests, and you'll see that in many different examples. Same thing here. So from one to the other. Again, we're not spending a lot of time with comparisons today. We're going to spend most of our time on transverse waves. Okay, so now that we know what the wave looks like, how we measure one wavelength, we can talk about if we see a wave in action, kind of like this, going across. We can measure how many we see, how long it takes for this to happen. Okay, so there's a couple different new terms that we got to talk about. So the first term is frequency. Okay, if I ask you how frequent you do something, you'll be talking about how the number of times you do it. Do you do it often? Do you not do it often? Are you very frequent in doing it? Are you not very frequent in doing it? So for this problem, or for this example, we're going to talk about the frequency for waves is it's the number of wavelengths that pass a fixed point each second. So if I say, for example, we say at this point right here, okay, and I said, or I can back it up, we'll say this point right here. How many wavelengths have passed in this 1 second? Okay, well, here's 1, here's 2, and here's 3. So that means that there's 3 wavelengths there. Okay, and we say that in seconds. We express that answer in hertz, which is the number over seconds. So in 1 second, it would be 3 waves in 1 second. So we'd say it's 3 hertz. That's the frequency. That's how often you see that happen. Okay. The next word is period. Okay. So this is the time, just the time it takes for one wavelength to pass a fixed point. Since we're talking about time, we express this in seconds. Okay? Oops, I'm sorry. So we can make some comparisons here. Okay? So as frequency increases, which would mean that if your frequency increases, your period is going to increase as well. Okay, so that kind of makes sense. I mean, if your time is going to take longer if you have more things pass. Okay, and also one other thing we got to talk about. So this is I guess you can say a proportional relationship. And as frequency increases, one last thing is we got to talk about is wavelength decreases. Oops. Erase that. Okay. So if wavelength decreases and frequency increases, let's talk about that. So here you can see this picture. It has a high frequency because in 1 second you see 1, 2, 3 pass. Okay, in 1 second here, say it's right here, this is 1 second, you see only 1 pass. So here's 1, and here there's 3. Okay, so this one has a high frequency, okay, because there's so many that pass in 1 second. Well, if we looked at the wavelength of one of these waves, you could say that we'll just measure this out. We'll just be hypothetical here. Let's say it's 1 centimeter. Okay? Well, that means that the wavelength is very short compared to how the frequency is. So you have a high frequency. So your high frequency, I guess just put it right there, and your wavelength is going to go down. I would write that in there just as an easy way to remember. Also, for this one, for example, if you have a low frequency, which means not a lot are going to pass in a certain amount of time, you can see that there's going to be a larger wavelength. So this might be 5 centimeters. So what happens is, pretty much, is that for this, you're going to see that if you have a high frequency, the distance between the two are going to decrease. It's like they're pushing together. They can't carry as far apart because of how many there are. And here, though, there's not that many, so they can stretch apart. Okay, so again, as frequency increases, the time it takes for one wave pass increases, and as frequency increases, wavelength decreases. Okay, we're going to talk about one more thing before we end the video, and that is we can actually figure out the speed of the wave. So the speed of the wave, we're going to call that v. Okay, we think of v in velocity. The wavelength, we're going to call a certain new term called lambda, and that's just sorry about that. That's just a new term where it's a Greek word, but we denote it with this symbol right here. And then the frequency, we just say, is f. Okay? So if we want to figure out how fast the wave's traveling, we need to know how many waves are passing in a certain time, and we need to know the wavelength of the wave, and we can find its speed. Okay? So in combining all that, we can say that the velocity of the wave, or the speed of the wave, is the f times lambda. Okay? Now, a couple little things to note if we're talking about speed is that light waves are faster than sound waves. And sound waves, they travel faster in solids and liquids than in gases. And light waves, they travel slower in solids and liquids than in gases or space. And we'll talk more about how they differentiate when we talk about what happens when you enter in different mediums like solids, liquids, or gases in the next video. And the last thing, the last slide we're going to talk about is amplitude. Okay, amplitude it's related to the amount of energy a wave carries. And again, we're always going to come back to this word while we're talking about this. So we can say that the greater the amplitude, the greater the energy carried. Okay, so how do you denote that is also, and I would put this in here, that amplitude, I'm just going to put amp, is equal to the height of the wave. Okay, so that means that the taller the wave, the more amplitude you have. Okay, and as you can see here, the amplitude's not great because the height's not great. And as you go increase the amplitude, the height of the wave gets bigger. So this is an example of volume. If you have a low volume on something, the amplitude won't be that good. If you have a higher volume, it'll be higher. Higher volume, higher. Okay? So that's all we need for now. Make sure you got all these notes down. Make sure you can pause, go back. Make sure you got everything you need. And be sure to take the quiz afterwards. Okay, thank you.